students, I hope all of you are doing good. Let's start today's chapter, whole numbers. So in this chapter, we're going to discuss about these given topics, right? Introduction. We have started studying this class from counting number 1, 2, 3 and so on. The counting numbers are also called natural numbers. We count the number of people in office, number of students, teachers, non-teaching staff in a school, number of male and female in a city, number of candies in a big jar. Sometimes number will be very large, like number of wheat grains in a container, but whatever numbers we get, if 1 is added to it, that will be larger than that number. So there is no largest natural number, but the smallest number is 1. Okay, 1 more than number is called successor and 1 less than the number is called predecessor. So in this chapter we are going to study about properties of whole numbers such as closure property, commutative property and associative property. Okay. If the predecessor of 1 is also included to the series of natural numbers, then numbers are called whole numbers. We shall also learn the representation of whole numbers on a number line. You know, your whole numbers start from 0, but natural numbers start from 1. Okay, no more. Predecessors and successor of all natural numbers are natural numbers, but predecessor of 1, that is a 0, is not a natural number. Counting number, because the smallest natural number is 1. Okay, whole numbers. When 0 is included in the counting numbers or natural numbers, they are called whole numbers. Thus, 0, 1, 2, 3, 4 and so on are whole numbers. It is interesting to note that, number 1, all natural numbers are whole numbers, but all whole numbers may not be natural numbers. Number 2, the smallest natural number is 1 and the smallest whole number is 0. Number 3, there is no largest natural number and whole number. The predecessor of 1 is 0, but there is no predecessor of 0. It is minus 1, which is not a whole number. We will learn in the chapter on integers. Okay. Representation of whole numbers on number line. We draw a line and mark a point O on it. Then divide the portion of the line towards a right of O in equal divisions. Okay. Like in this case. These divisions will represent whole numbers in increasing order. That is, O will represent 0, P will represent, what is P representing 1, and then Q will represent 2, R will be 3 and so on. Thus, numbers towards right of any number will be greater than the number towards left. Thus, whatever numbers are represented by A, B and C according to number line, A is less than B and B is less than C. Can you tell a number which is towards left of 75 and which number is to the right of it? All the numbers less than 75 such as 74, 73, 72 etc. towards left and 76, 77, 78 etc. towards right of 75. If we observe the number line, we come to know the following properties of whole numbers. Number 1, smallest and largest whole numbers. 0 is the smallest whole number. On the number line, there is no whole number on the left of 0. There is no largest whole number, okay, but there is a smallest whole number, which is 0. Number 2, successor and predecessor. You are already familiar with these two terms. 1 is 1 more than 0, 2 is 1 more than 1, 3 is 1 more than 2 and so on. Hence, 1, 2, 3, 4 are successors of 0, 1, 2, 3 and so on respectively. Now, in the reverse order, 0 is 1 less than 1, 1 is 1 less than 2 and 2 is 1 less than 3 and so on. So, 0, 1, 2 are called predecessors of 1, 2, 3 respectively. No more. Thus, the number immediately to the right of a particular number on a number line is called its successor. 0 is not the successor of any whole number, right? And next, thus, the number immediately to the left of a given number on the number line is called the predecessor of that number. 0 is only whole number which has no whole number predecessor, right? Order property. Number 1, every whole number on the number line is greater than every whole number on its left. For example, 10 is greater than 8, 8 is greater than 4, 3 is greater than 2, etc. B. Every whole number on the number line is less than every whole number on its right. For example, 8 is less than 10, 4 is less than 8 and 2 is less than 3, right? Number 4, betweenness. The number line displays the property of betweenness. For example, 6 lies between 4 and 8, okay? As you can see, 6 is lying between 4 and 8, right? Remember, A, where the whole numbers 5, 6, 7 are between 4 and 8. B, whole numbers between 4 and 8 means 4 and 8 will be excluded, okay? Means whenever we are finding numbers between any two numbers, the given numbers will not be included. Remember that, okay? See, if whole numbers are from 4 to 8, then 4 and 8 both will be included. Means if this term is used, like we have to find the numbers from this number to this number. For example, we have to find out the numbers from 4 to 8. Now, we will include 4 and 8 also, okay? So, the numbers will be 4, 5, 6, 7, 8. D. Try these questions, find whole numbers between these two numbers and from 0 to 5 between 999 and 1000, okay? So, you will do it. Addition of whole numbers on the number lines. Addition of whole numbers can be done on number line. Let us find 2 plus 5, okay? So, we start from 0 and move 2 steps to the right of 0. We reach at Q, okay? This position is Q. We then start from Q and further move 5 units, okay? Then we reach at V, okay? Now, we represent the sum of 2 and 5, that is 7 on the whole number, okay? Solution tips: 3 plus 7 and 2 plus 9, 8 plus 3, etc. by the same method, or 0 plus 8. We start from 0 and remain at 0, no step. Then move 8 steps to right of 0. We reach to point W, so answer is 8, okay? Now, subtraction of whole numbers on the number line. Subtraction of two whole numbers can be done on number line. Let us find 6 minus 4, okay? See this number line? We start from 0 and move 6 steps to the right of 0, okay, because we have to subtract 4 from 6. We reach at U, which is 6, okay. We then start from U and move backward 4 steps to left of U. Why backward? Because here we are doing subtraction, okay. And one more reason is given here, as subtraction is a reverse process of addition, okay. So, in addition, we moved further, but in case of subtraction, we will move left side, okay. That is backward. So, we reach at Q in left of U. Now, Q, that is 2, represents the difference of 6 and 4. So, 6 minus 4 is equals to 2. Solution tips: try the following: 8 minus 5, 6 minus 3, 9 minus 4, 3 minus 8 by this 8. For last one, that is 3 minus 8. We start from 0 and move 3 steps to right of 0. We reach at R. Okay, R is 3, right? Next, then we start from R and move backward, that is 8 steps to left of R. It is not possible because leftmost point is what? 0. How can we move 8 steps backward? Like, we'll start from here, 3, 1, 2, 3, but how can we move 5 steps backward? So, it is not possible because leftmost point is 0 and we cannot take steps and left of it. So, it will not be a whole number, okay. Condition for subtraction of whole numbers is first whole number should be greater than or equal to second whole number, right. Next, multiplication of whole numbers on the number line. We can also multiply two whole numbers on the number line. Let us find 2 into 3. See this figure? To find 2 into 3, we start from 0 and move 3 steps of 2 units, okay. 1, 2, 3, okay. We moved 3 steps of 2 units, right. So, we reach at U, which is what? 6. So, 2 into 3 is equals to 6. Solution tip: multiplication is a repeated addition. That is, 2 into 3 means 2 is added 3 times. So, 3 moves of 2 steps each are required. First move is from O to Q, second move is from Q to S, and third move is from S to U. So, 2 plus 2 plus 2 is equals to 6, right. Example 1, write the successor of these numbers. Students, you already know how to find the successor. Okay, so you will do it by yourself. You will just add 1 to these numbers to get the successor, right? In example 2, you have to find the predecessor of the given number. So what will you do? You will just subtract 1. Okay. Now let's check out what are the common mistakes in predecessor and successor. Predecessor and successor are very common words, but we do frequent mistakes of doing just opposite of what is asked. So first, read carefully. Number 2, don't do with pre-decided mind. 3, check it after doing. And 4, don't do mentally add 1 or subtract 1 as done here in example 2. Right, students? Properties of whole numbers. All the 4 basic mathematical operations such as addition, subtraction, multiplication and division can be performed on whole numbers. Now we shall discuss the properties of whole numbers such as closure property, commutative property, associative property and distributive property, etc. Number 1, closure property of addition of whole numbers. Okay, let us add 2 whole numbers. Let's say 4 plus 11 is equals to 15, 12 plus 13 is equals to 25 and 91 plus 12 is 103. All these sums, that is 15, 25, 103 are whole numbers, right? No more. Thus we can see that sum of 2 whole numbers is always a whole number, that is whole numbers are closed under addition. This property is called closure property, which can be stated as if P and Q are 2 whole numbers, then their sum P plus Q is also a whole number. Okay. Commutative property of addition of whole numbers. Let us add any 2 whole numbers. You can take any whole number. See, 9 plus 12 is equals to 21 and now we have changed the order, that is 12 plus 9 is equals to 21. So interchange of place of whole numbers in addition is called commutative property of addition. Okay. Thus, we observe that the sum of 2 whole numbers remains the same irrespective of the order in which we add them. That is, places are interchanged. This property is called commutative property of addition of whole numbers. It can be stated as if P and Q are 2 whole numbers, then P plus Q is equals to Q plus P, right? Associative property of addition of whole numbers. Let us take any 3 whole numbers and add them by changing their order. For example, 4 plus 6 plus 9. Okay, so 4 plus 15 is equals to 9, right? Also, 4 plus 6 plus 9 is what? 10 plus 9 is equals to 19. Similarly, in this case also, the sum will remain same. Thus, we see that if 3 numbers are to be added, the sum remains unaltered by changing the position of the brackets in which they are added. So, this property is called associative property of addition of whole numbers. Thus, the property can be stated as if P, Q and R are 3 whole numbers, then P plus Q in bracket plus R is equals to P plus Q plus R in bracket, right? This property also helps in adding 3 or more numbers conveniently, and let us look at the following example. But first, let's know the solution tip. Change of grouping, that is bracket of whole numbers in addition, is called associative property. Example 1. 531 plus 450 plus 461. Okay, so here what will we do? This is 539 plus 450 plus 461 in bracket. Okay, so this is what? If we change the order, 539 plus 461 plus 450. So this is what? This is commutative property of addition. Okay, now 539 plus 461 in bracket and 450. Okay, so this is associative property of addition, and what will you get here? 1000 plus 450, that is 1450. Okay, remember sometimes we use 2 or more properties of addition in same question. Since a solution is simple but based on basic rules, so in each step write the name of the rule as we did in this example. Okay, now next is additive property of 0. Let A be any whole number, then A plus 0 is equals to what? A plus 0 is A and 0 plus A is also A. Okay, so 8 plus 0 is equals to 8 and 0 plus 8 is equals to 8. That is the sum of any whole number and 0 is the number itself. This property is called the additive property of 0, which you already know. That is, 0 is called the identity for addition, right? Example, find the sum of the following by making suitable arrangements by the help of basic properties. Okay, so you have to find out the sum of these numbers. So first, what will we do? 498 plus 302 plus 334 in bracket. This is the commutative property of addition. Now, 498 plus 302 in brackets plus 334, this is associative property of addition. So 800 plus 334, make use of the fact that 8 plus 2 is equals to 0. Okay, so then we'll add, so this is the sum. Similarly, you will do part 2 also, right? Now let's do the exercise. Question number 1. Answer the following, which is the smallest natural number? You know that very well, which is the smallest natural number is 1. And which is the smallest whole number? Smallest whole number is 0, right? Properties of multiplication of whole numbers. Closure property of multiplication of whole numbers. Let us see what we get when we multiply two whole numbers. 14, see, 14 into 8 is equals to 112. So we are multiplying two whole numbers and the product is a whole number. So it shows that when we multiply two whole numbers, the product is also a whole number. No more. This product of two whole numbers is also a whole number. This is called closure property of multiplication of whole numbers. It can be stated as if P and Q are two whole numbers, then their product P and Q is also a whole number. Okay. Next is commutative property of multiplication of whole numbers. Try to calculate. 4 into 8, 14 into 8 is equals to 112 and 8 into 14 is also 112. That means 14 into 8 is equals to 8 into 14. Okay, similarly, this will be equal. That is, if we multiply two whole numbers, the product remains the same even we interchange the places. Okay, so no more. The product of two whole numbers remains unaltered by interchanging the place in which they are multiplied. This property is called commutative property of multiplication of whole numbers. It can be stated as if P and Q are two whole numbers, then P into Q is equals to Q into P. Okay. Next is associative property of multiplication of whole numbers. Take any three whole numbers and find their product in the following ways. 6 into 9 into 8 is equals to 6 into 72 is equals to 432. Now, 6 into 9 in bracket, then into 8. 6 into 9 is 54, into 8 is also equals to 432. Okay. So, we see that the product of three whole numbers remains same irrespective of the order in which they are multiplied. That is the changing of brackets. This property is called associative property of multiplication of whole numbers. It can be stated as if P, Q and R are in three whole numbers, then P into Q into R is equals to P into Q in bracket into R, right? Multiplicative property of 0. Let A be any whole number, then A into 0 is equals to 0 into A, that is 0. So 6 into 0 is equals to 0. You know that if we multiply any number by 0, we get answer 0. That is, any whole number multiplied by 0 gives a product 0, and this property is called the multiplicative property of 0. Okay. Multiplicative property of 1. Let A be any whole number, then A into 1 is equals to 1 into A is equals to A. For example, 7 into 1 is equals to 1 into 7, because product of 7 into 1 is 7 and 1 into 7 is 7. So, any whole number multiplied with 1 gives the number itself. This is called multiplicative property of 1, and 1 is called the multiplicative identity of whole numbers. Next is a distributive property. The distributive property states that multiplying a sum by a number gives the same result as multiplying each added by the number and then adding the products together. See, A into B plus C is equals to A into B plus A into C. No more. This property is known as distributive property of multiplication over addition. Okay. So, where A, B, C, here A, B, C and are your whole numbers, right? The distributive property of multiplication over addition and subtraction. About this we have also studied in chapter 1 also, right? So, here you can see the figure. So we notice from above figures that 2 into 5 is equals to 10, okay, and 2 into 2 is equals to 4 and 3 into 2 is equals to 6, and when we add these products, that is 4 and 6, we get a 10. So 2 into 2 plus 3 is, we can also write it as 2 into 2 plus 2 into 3, okay. Remember, for subtraction of whole numbers, there is an important condition that out of two numbers which are subtracted, first number should be greater than second number. As here 4 is, in this case 4 is greater than 3. That is 4 minus 3 is equals to 1 is whole number. If it is 3 minus 4, then it will not be a whole number. Okay. Let's do the example. Is 6 into 5 plus 3 into bracket is equals to 6 into 5 plus 6 into 3. Of course, this is true, okay, or if not, then you can find the product also. See, 6 into 5 plus 3 is 6 into 8, your product is 48. Now, 6 into 5 plus 6 into 3, 6 into 5, 30 plus 6 into 3, 18. And the answer is 48. So, this statement is true, right? No more. Distributive law is used in two ways. A. Sometimes bracket is solved to get a single number, then outer number is multiplied, and it is done in example 10, part 1. A into B plus A into C is equals to A into, then in bracket, B plus C. B, sometimes we open the bracket first and after individual multiplication, results are added or subtracted as it is done in example 10 part 2, 3, that is A into B plus C is equals to A into B plus A into C, and A into, then in bracket B minus C is equals to A into B minus A into C. Now, subtraction of whole numbers. If we subtract 10 minus 4 is equals to 6, where 6 is whole number, but 4 minus 10 is equals to what? Is equal to minus 6, which is not a whole number. Here you will notice that to get a whole number as answer, there is a condition. Okay, what are the conditions? Let's check out. First number should be greater than the second number for subtraction if you want to get a whole number, right? Let us check the properties of subtraction. Number 1, closure property. 15 minus 9 is equals to 6 is a whole number, but 8 minus 10 is not a whole number, because 8 minus 10 is minus 4, which is not a whole number. So, subtraction of two whole numbers is not always a whole number. Remember that. So, right. Subtraction doesn't obey closure property. If A and B are whole numbers, then A minus B is a whole number if either A is greater than B or A equals to B, right? Number 2, commutative property. 4 minus 5 is equals to minus 1 and 5 minus 4 is equals to 1. So, 4 minus 5 is not equal to 5 minus 4, okay? Subtraction of two whole numbers doesn't obey commutative property if A and B are distinct whole numbers, where A minus B is not equal to B minus A, okay? Interesting fact, volleyball became an official Olympic sport in year 1964. The sport of basketball was invented as 73 years before volley become an Olympic sport. In which year was basketball invented? Here, years before implies subtraction. That is 1964 minus 73 is equals to year 1891. Try to make 5 such problems related to any sports where you can use subtraction and record important information in your diary. Okay. No more. Remember, subtraction of two whole numbers is not always a whole number. The subtraction of two or more whole numbers does not follow any of the property, like a closure property, it doesn't follow. Commutative property, it doesn't follow. Associative property, it doesn't follow. Also, there is no identity element of subtraction of whole numbers, right? Number 3, associative property. 16 minus 8 minus 5 is not equals to 16 minus 8 in bracket and minus 5, because in this case, what will we get? See, 16 minus 8 minus 5 is what? 16 minus 3 is 13. But 16 minus 8 minus 5. What will we get? 16 minus 8 is 8 and minus 5 is 3. As 13, so you can see 13 is not equal to 3. So subtraction of 3 whole numbers doesn't obey associative property. If A, B, C are 3 distinct whole numbers, then A minus B, then in bracket B minus C is not equal to A minus B in bracket, then minus C, right? Number 4, identity element. 0 minus 5 is equals to minus 5. Minus 5 is not a whole number, and 5 minus 0 is equals to 5, which is a whole number. So subtraction of whole numbers, it does not have identity element. Okay, that is 0 minus A is not equal to A minus 0. Okay, now division of whole numbers. Maths extension. Take a few whole numbers in pairs and divide the first number by second number. Check whether we are getting the quotient as a whole number without remainder or not. 14, 7 and 32, 4, these are the pairs which you have to divide. 21 and 2, 45 and 4. You take few more pairs of non-zero whole numbers. 0 will be discussed later. Let us look at the above example. Number 1, 14 divided by 7 is equals to 2. So here 14, 7 and 2 are whole numbers, so quotient is a whole number. Okay. Number 2, 32 divided by 4 is equals to 8. Here quotient is a whole number again. Number 3, but 22, 2 both are whole numbers, and 21 divided by 2 is what? 21 by 2, which is a fractional number and not a whole number. Okay. Similarly, fourth part, 45 divided by 4 is also not a whole number. Okay, no more. Remember, like subtraction, division of two whole numbers is not always a whole number. Thus, it doesn't obey the property like closure property, associative property and commutative property. Also, there is no identity element of division of whole numbers, right? Let us check these properties for division. Number 1, closure property. See, if 15 is divided by 8 is not a whole number, but 15 and 8 both are whole numbers. But 63 divided by 4 is equals to 9 is a whole number. So, a whole number divided by the other whole number is always not a whole number. Okay. So, division doesn't obey closure property. Number 2, commutative property. Okay. See, 14 divided by 7 is equals to 2, but 7 divided by 14 is not equal to 2. Okay. So, division of two numbers doesn't obey commutative property. If A and B are distinct whole numbers, then A divided by B is not equal to B divided by A. Okay. No more. Some important points are related to divisibility of 1 and 0 for whole numbers. Okay. Number 1, when any whole number is divided by 1, we get the same number as answer. So, if P is a whole number and it is divided by 1, then we get the answer P. For example, 9 divided by 1 is equals to 9 and 15 divided by 1 is equals to 15. You already know that, right? Number 2, when a non-zero whole number is divided by itself, we get 1 as number. That is, P divided by P is equals to 1. You can take any number like 8 divided by 8 is equals to 1. 12 divided by 12 is equals to 1. Here P is a whole number. Number 3, when 0 is divided by any other a non-zero number, we get 0 as answer. If P is a whole number, okay, so 0 divided by P is equals to 0, right? Number 4, for any whole number is divided by 0, it is undefined, okay. So, 7 divided by 0 is undefined, right? Associative property. 24 divided by 8 is equals to 3. Divided by 8 is equals to 3 is not equal to 24 divided by 8 divided by 3. Okay. So, here 24 divided by 8 divided by 3 is equals to 3 divided by 3 is equals to 1, but 24 divided by 8 divided by 3, here 8 divided by 3 is not a whole number, so for whole numbers it will not be solved. If solved, what will we get? 24 divided by 8 by 3 is equals to 24 into 3 by 8, okay, which is 9. Okay, and it is not equals to 1, right? So, division of three whole numbers does not obey associative property. If A, B, C are three distinct non-zero whole numbers, then A divided by B divided by C in bracket is not equals to A divided by B in bracket divided by C. Division by 0 is a special case, so it is discussed later, right? Number 4, identity element. In multiplication, 1 is identity element as A into 1 is equals to 1 into A is equals to A. Like that in division, identity element is not possible because 5 divided by 1 is equals to 5, but 1 divided by 5 is not equal to 5. It is not a whole number. So division of whole numbers doesn't have identity element, that is 1 divided by A is not equal to A divided by 1 is equals to A, right? Now division of whole numbers by 0. Multiplication by a number means adding that number repeatedly. Example for 15 into 4. Here 15 is added 4 times. So this is the first move, then second move, then third move and fourth move. So here 60 is the answer. Similarly, division by a number means a subtraction of that number repeatedly till we reach to 0. Then only a whole number answer will be obtained. Example for 36 divided by 9, where 9 will be subtracted from 36 repeatedly till we reach to 0. 36 minus 9 is 27, 27 minus 9 is 18, 18 minus 9 is 9 and 9 minus 9 is 0. This is how many moves we have made? 4. Since we got 0 after 4 moves, so 36 divided by 9 is equals to 4. No more. Divide 5 by 0. Using the property of division as subtraction of that number repeatedly. 5 minus 0 is equals to 5. 5 minus 0 again is equals to 5. 5 minus 0 is equals to 5. 5 minus 0 is equals to 5. Up to so on. In every move we get a 5 again as an answer. Will this ever stop? No. So we can say 5 divided by 0 is undefined, means not defined. Any whole number divided by 0 is not defined. Okay. Example 1. Fill in the blanks that make each of the following a true statement. Also write the name of the property. So here you have 268 plus 529 is equals to 529 plus a dash. So which number will come here? This number will come here, 268. And which property is this? This is commutative property. So every time you have to write property, name of the property also, right? Now let's do exercise 2.2. Fill in the blanks. 47 into 25 is equals to 25 into what? Into 47. Okay. Now, some interesting rules of easy multiplication by 5, 25 and 125. Multiplication by 5. First, 5 into 2 is equals to 10. 5 and 2 are complementary. So, instead of multiplication by 5, divide the number by 2, which is easier. Number 2, obtain the quotient and 2 remainders are possible, either 0 or 1. Number 3, answer will be the quotient with 0 at units place if remainder is 0 and B quotient with 5 at units place if remainder is 1. Okay. So, try to fill in the blanks as directed. Okay. See, 1721 into 5, dividend is 1721, divisor is what? 2. Okay. And the quotient is 810. How will we get 810 a quotient? You will have to divide it. Okay, so let's divide it by 2. 2 8s are 16, 1 will bring down 2, 2 6 are 12, then 1, there is no more digit, zeros. Okay, so this is remainder and this is quotient. So we will write quotient here. 810 here it is written, but it will be 860. Okay, and then there is remainder 1. So number at unit place will be 5. So the final answer would be your, here it is written 8105, but the answer is 8605. Okay. Okay, now similarly you will do other parts also. Okay, so it is very easy to multiply a number by 5, right? Now, multiplication by 25. Number 1, since 25 into 4 is equals to 100, they are complementary. So, multiplication by 25 also implies division by 4. Division by 4 is obviously easier than multiplication by 25, right? Number 2, obtain the quotient and look at the remainder. Number 3, answer will be the quotient along with last 2 digits, that is tens and units place as 00 for 0 remainder and 25 for 1 remainder, 50 for 2 remainder and 75 for 3 remainder. Okay, let's try to solve this, then we'll get this now. Okay, see, you have 29817 into 25. Okay, so first we will divide this number by 4. Okay, 29817 divided by 4. 4 sevens are 28. 1 will bring down 8. 4 fours are 16. 2 will bring down 1. 4 fives are 20. 1 and then we'll bring down 7. 4 fours are 16. Okay, so 1 is the remainder and this is quotient. Okay, now remainder is 1. In case of 1, what will we do? In case of remainder, last 2 digits will be 25. Okay, so 7454 quotient and then we'll add 25. So this is the answer. That means when we will multiply this number by 25, we will get this product. Right? Isn't it easy? Now next check multiplication by 125. Since 125 into 8 is equals to 1000, they are complementary to each other. Multiplication by 125 also implies division by 8, which is obviously easier. Number 2, find the quotient. Your remainder will be 0, 1, 2, 3, 4, 5, 6 or 7. Number 3, final answers will be the quotient with the last 3 digits, that is ones, tens and hundreds place as follows. For remainder 0, the last 3 digits are 30. For remainder 1, the 3 digits are 125. For remainder 2, the 3 digits are 250. Okay. Similarly, for remainders 3, 4, 6 and 7, the last 3 digits are 375, 500, 675, 750 and 875 respectively. Okay. Let's try to fill in the blanks. Okay. So we have this question, 2953 into 125. Okay. So this is the dividend, means we will divide this number by what? 8. Okay, 8 threes are 24. 5, then 5. Now 8 6 are 48. 15 minus 8 is 7 and 3. 8 9s are 72. Okay, now here remainder is 1 and this is the quotient. So in case of 1, what will be the last 3 digit? Last 3 digit will be 1, 2, 5. Okay, and final answer would be 3, 6 and 9. So this is the answer when we will multiply these two numbers. Okay. Now some tricks or shortcuts for easy multiplication by 5, 15, 25, 35, 45. Provided the number is multiple of 2. Okay, the condition is also here. The number should be 2. That is an even number. 32 into 5 is equals to 32 into 10 divided by 2. Okay, so what will we get? 16 into 10. Right. Number 2, 32 into 15 is equals to 32 into 30 divided by 2. Why 30 divided by 2? Because if you divide 30 by 2, we will get 15. Okay, then 16 into 30 is equals to 480. Okay. Next, 32 into 25. Okay, how will we get 25? By dividing 50 by 2. Okay, now 16 and 16 into 50 is equals to 800. Okay, some interesting patterns in whole numbers. Number 1, multiplication patterns of 9s. Look at the pattern given below and by using the hidden trick, try to write 3 more. See, 1 into 9 plus 1 is 10. Now 12 into 9 plus 2 is equals to 110. And 123 into 9 plus 3 is equals to 1110. Okay, so can you observe this pattern? Here numbers are increasing, like 1, then 1, 2, then 1, 2, 3, then 1, 2, 4. And here number of ones are increasing. Okay, so here how many numbers are there? 1, 2, 3, 4, 5. So you will write here 5, 1. 1, 2, 3, 4, 5 and then 1, 0. Right? Pattern number 2. 9 into 9 plus 7 is 88. 98 into 9 plus 6 is equals to 888. 987 into 9 plus 5 is equals to 8888. Now, what will come here? 88, 88, then 8. Okay. Similarly, you will do pattern 3 also. Number 2, addition pattern of odd and even whole number. Now, pattern number 4, odd number. 1 is equals to 1 is equals to 1 into 1. 1 plus 3 is equals to 4 is equals to 2 into 2. See, these are making square numbers. Okay. 1, 2, 3, 4, 5, 6. How many odd numbers are there? So, 6 into 6 is equals to 36. 1, 2, 3, 4, 5, 6, 7. How many odd numbers are there? 7. So, 7 into 7 is equals to 49. You can also check it by adding all these numbers. Okay. Hidden rule. Sum of first n odd natural number is n into n. Now, pattern number 5, even number. 2 is 1 into 1 plus 1. Then 2 plus 4 is 6. That is 2 into 2 plus 2. The number 2 plus 4 plus 6. There are 3 odd numbers. So, 3 into 3 plus 4. 3. Then in this case, there are 4 even numbers. So, 4 into 4 plus 4. Then in this case, there are 5 even numbers. So, 5 into 5 plus 5. 5 into 5, 25. Plus 5, 30. Okay. Hidden rule, sum of first n even whole numbers is n into n plus n, where n is a natural, where n is a number. Okay. Some beautiful multiplication patterns of ones. See the pattern and try to see the hidden rule and fill in the blanks. Here, pattern number 6. 1 into 1 is 1. 11 into 11 is 121. Then 3 times 1 into 3 times 1. Then 1, 2, 3 and then 2, 1. Okay. Then 4 times 1 multiplied by 4 times 1. 1, 2, 3, 4 and then 3, 2, 1. That is, we are writing it in backward counting. Okay. So, now 5 times, you have 5 times 1 multiplied by 5 times 1. So, you will write here 1, 2, 3, 4, 5, then backward 4, 3, 2, 1. Right. Pattern number 7. 1 into 11 is equals to 11. 11 into 11 is 121. Now, 11 is same here. Here number of ones are increasing. Then 111 into 11 is equals to 121. Okay. Now, 1 is 4 times multiplied by 11. 1, 2, 2, then 2, 1. Okay. That means here 5 times 1 multiplied by 11. So, what will you get here? 1, 2, 2, 2, 2, 1. Okay. Pattern number 8 is 1 into 111, 111. 11 into 111. Okay. You will all try to find out what kind of pattern is this and this one also. Okay. And hidden rule, pattern work in following way. 12 is equals to 11 plus 1. 123 is equals to 111 plus 11 plus 1. 1234 is 1111 plus 1111 1111 plus 111 plus 11 plus 1. Okay. So, dot patterns in whole numbers. The whole numbers can be used to make some basic shapes of geometry by using dots. Rule. Here it is allowed to make a line. Number 2, isosceles right angled triangle. Isosceles triangle means angles with 2 sides equal and angle between them is 90 degrees. Number 3, square or rectangle. We are not allowed to use any other shapes. One is a special number because it can make only one dot which can represent a point only. Okay, no more. Number 2, that is 2 dots can represent any one line but not the triangle, rectangle or square. Okay. Number 3, 3 dots can represent what? A straight line also, or a triangle but not a square or rectangle. And number 4, that is 4 dots can represent a straight line and a square but not a triangle or rectangle. Okay. Number 5, that is 5 dots can represent a straight line but neither square, rectangle nor triangle. Okay. So, here dots are equally spaced. Make a table to show that from the numbers from 1 to 16 which all geometrical dotted shapes are possible. Okay, so you'll do it. And there is hint also for number 16 in dot pattern, line is possible, square are possible. For example, this one and rectangle. And 10 dots can form line, rectangle and triangle. Why? You will give the reason. So students, I hope you have understood this chapter. Now you will do practice of this chapter by yourself.